Hi everyone, welcome back to Lulumath. This video is on using systems of equations to solve a word problem. This is video number 2, so make sure that you catch the video that came before this one and any other videos coming after this one to fully understand how to use systems of equations to solve word problems. So in our example right here, we have a kayaker that traveled 14 kilometers down a river in 2 hours. On the way back, the kayaker traveling against the current took 3.5 hours. What was the average rate of the kayaker and what was the rate of the current? So in our last video, we had some steps that we could follow to help us to properly set up and solve these types of word problems. So step number 1 is to identify what you know. So we know that a kayaker traveled for 14 kilometers and it took him, he was going down a river, that's important, and it took him 2 hours, okay? We also know that the kayaker was traveling on the way back against the current and took 3.5 hours, but went the same distance. Okay, then we need to identify what we want to know. Identify what you want to know. Well, I want to know what the average rate of the kayaker is, as well as the rate of the current. Okay, so I have in green highlighted what I want to know. So step number 3 says to draw a picture or diagram if you need to. And drawing a picture here is actually going to help us out. So the kayaker is going down the river, okay, and the kayaker is going a distance of 14 kilometers. So we know that our kayaker is going down this river and is going 14 kilometers, and we know that it's taking the kayaker 2 hours. Okay, and as the kayaker is going, the kayaker's traveling with the current. So the current is pushing him faster right here. So we know that the current is making him go faster than his actual speed. Then on the way back, he's still going 14 kilometers here, but this time he's going back to where he started. So this time he's going against the current. So the current is still going this way. Now he's fighting against the current, okay? And we know that this will take him 3.5 hours, okay? So drawing this picture is going to help us out. Now we need to write specific let statements. And remember, always ask yourself, what do I not know? Okay, so I don't know how fast the kayaker is going. That's an unknown for me. So I'm going to say, let the rate of the kayaker equal X, okay? And remember, we want to be specific with our let statements. So we have to say it's the rate of the kayaker. Don't just say rate, because we also don't know the rate of the current. So we have to write a second let statement for the rate of the current. So again, we have to be specific so we know which one we're talking about. And that's going to equal Y, okay? So really quickly, before we move on to writing our equations, I just want to remind you guys that distance is equal to the rate times the time. So as the kayaker is going down right here, the river, so that's our information that's highlighted in purple right here. As the kayaker is going down, his or her distance is 14 kilometers. The rate is going to be the how fast the kayaker is going, and because he's going down the river, then the current is helping this person go faster. So the rate is the sum of the rate of the kayaker plus the rate of the current, because the current is pushing him or her farther along. So the rate is going to be equal to x plus y, and we know that it took that person 2 hours. Okay, now on the way back, which is what we have highlighted in blue, okay, we know that the kayaker still traveled 14 kilometers. So that's the distance right here. We know that this time the rate is going to be slower. The kayaker is going X kilometers per hour, but the current is slowing this person down. So instead of adding them together, we're going to subtract them because the rate is slower. So that's the rate right here. And we know that we want the time. We know the time took 3.5 hours. So we're going to write uh, 3.5 here. Okay, now I just need to go ahead and solve. So in order to solve this, what I'm going to do is I'm actually going to divide out this 2 right here because then I don't have to deal with distributing or anything along those lines, especially since 14 is evenly divisible by 2. And this is pretty much all I have on the right side of my equation. So 14 divided by 2 is 7. So 7 equals x plus y. Okay, and then I'm going to do the same thing for my blue equation. So I'm going to divide everything by 3.5, and I end up getting 4 equals x minus y. Well, this is nice. I can put them on top of each other, and all I have to do is add my equations together because this positive y and this negative y will cancel each other out. So 7 plus 4 is equal to 11, and x plus x is equal to 2x. Divide both sides by 2, and I get 5.5 equals x right here. Well, I know what x is, but I still have to figure out what y is. So I'm going to take one of my equations. So let's take this 7 equals x plus y equation here. You have a lot of choices. You can use this 14 equals x plus y times 2, this 14 equals x minus y times 3.5, or you can use the simplified equations after we divided by the purple one by 2 and the blue one by 3.5, because the purple equations are equivalent to each other and the blue equations are equivalent to each other. So 7 equals x plus y. Well, I know that x is 5.5 here. So I'm going to replace that in here. So 7 equals 5.5 plus y. Okay, now all I have to do is just subtract this 5.5 from both sides, and I end up getting 1.5 equals y. So I'm all set. I'm done. I know what x is and I know what y is. I know x is 5.5 and I know y is 1.5. So let's go back to our let statement. So that means that the rate of the kayaker is this 5.5 that we have here. So 5.5 kilometers per hour. And then we know that y is 1.5, so that means that the current is going 1.5 kilometers per hour. So we can go ahead and write our therefore statement. So we can say the kayaker is traveling at a rate of 5.5 kilometers per hour, and the current is going at a rate of 1.5 kilometers per hour. And that's our final answer. But we're not done because we want to ask ourselves, does our answer make sense? So if you look here, this kayaker is going down at a rate of 5.5 kilometers per hour, but the current is also going at a rate of 1.5 kilometers per hour. So that means that combined, the kayaker is and the current together are traveling at a rate of 7 kilometers per hour. Well, 7 kilometers per hour for 2 hours is going to take us a distance of 14 kilometers. So this sounds like it's going to work for us. Okay, now as the kayaker is going back, he or she is going 5 kilometers per hour, 5.5 kilometers per hour, and the current is slowing him down by 1.5 kilometers per hour. Okay, so we can say here that 5.5 minus 1.5 is equal to 4 kilometers per hour. Well, 4 kilometers per hour for 3.5 hours will also get us a distance of 14 kilometers. So we know that our answer does make sense. Okay, that's it for this video. If you have any questions, please let me know in the comments below or at lulumath.com. Make sure to stay tuned and watch the next video on word problems. And you can find these notes on my website at lulumath.com. Please subscribe and share this video. Have a great day. See you next time.